In the previous video, we learned about permutations, where the order of arrangement was very important. Now let's look at another type of counting problem where the order does not matter. This concept is called combinations. Let's understand it with a simple example. Suppose there are three tennis players X, Y, and Z, and we want to form a team of two players. How many different teams can we make? At first, you might think that XY and YX are two different teams. But are they really different? The answer is no. Both represent the same two players playing together. Unlike permutations, changing the order does not create a new selection. This is the biggest difference between permutations and combinations. In permutations, order matters. In combinations, order does not matter. So the possible teams are simply XY, YZ, and ZX. That means there are only three possible teams. Now let's look at another real-life example. 12 people are standing in a room and each person shakes hands with every other person. How many handshakes take place? Notice that if A shakes hands with B, it is exactly the same handshake as B shaking hands with A. Counting both separately would be incorrect. Since order is not important, this is a combination problem. Similarly, suppose 7 points lie on a circle and we want to draw chords by joining any 2 points. A chord joining point A and point B is the same as the chord joining point B and point A. Once again, order does not matter, so combinations are used. Now let's derive the formula for combinations. Suppose we have four different objects A, B, C, and D, and we want to choose any two of them. The possible selections are AB, AC, AD, BC, BD, and CD. Notice that BA is not written separately because BA represents the same selection as AB. So there are 6 combinations. Now think about one of these combinations, say AB. If we arrange these two letters, we can write AB or BA. That means every combination of two objects can be arranged in 2 factorial different ways. In other words, every combination produces multiple permutations. This gives us an important relationship. The number of permutations is equal to the number of combinations multiplied by the number of arrangements of the selected objects. In mathematical form, n permutation R is equal to n combination R multiplied by R factorial. Now we already know the formula for permutations. Substituting that formula, we get n combination R equals n factorial divided by R factorial multiplied by n minus R factorial. This is the standard formula for combinations, and it is one of the most important formulas in this chapter. It helps us solve selection problems without listing every possibility. There are also a few special results that are useful to remember. First, if we choose all the objects, there is only one possible selection. For example, choosing all 5 students from a group of 5 can happen in only one way. So n combination n is always equal to 1. Similarly, choosing 0 objects can also happen in exactly one way, by selecting nothing at all. So n combination 0 is also equal to 1. These two results appear very frequently in examinations. Now let's quickly summarize the difference between permutations and combinations. If the order of objects changes the answer, use permutations. If only the selection matters and changing the order does not create a new result, use combinations.